Hi, welcome to another episode of Makers at Amherst Media. I'm Charlie Schweik. I'm a faculty at UMass Amherst with the Environmental Conservation Department and the School of Public Policy. I'm stepping in for our normal moderator, Steve Brewer, who wasn't able to be here today, but I'm happy to be here, and I'm also introducing a course that we've been doing at UMass called Makerspace Leadership and Outreach. In a few minutes, I'm going to be bringing up some of the students that took the course this past semester. They're just terrific students, most of them with the engineering program, not all, and we're going to be talking about three different projects that they've been working on. But before we started, I want to give the audience a little bit of a introduction about making. Most people watching this probably know what it is, but in case you don't, the maker movement, it's really about do-it-yourself things or do-it-together type projects. This particular, that's something that people have done for a long time, but this came out of the Make magazine era. It came out about maybe 8 years ago, and there's a screenshot cover of a Make magazine that came out of. If any of you have gone down to New York City, in September, there's the world, they call it the greatest show and tell on earth. It's the International Maker Fair in New York City, down by Met Stadium. And it's really quite a spectacle to go down and see it. And this screenshot shows part of that event. The thing that struck me as I've gone down there, and I've taken students down there a number of times, is that a lot of the Maker fair in New York City is about gadgets. It's a lot of fun things. People are doing a lot of fun things with technology. But what struck me is that there was not as much science that's actually there as what I think there should be. So that brings me to the first point I want to make. As I go through this episode with my students, I'm going to be making a couple points. But there's really the need and the potential, a great potential of what I call makerspace science. And one of the things we're trying to do with Makers at Amherst Media is connect to the 5 colleges, doing maker-related work around the things that students are learning about. And not only that, but also connecting to the high schools and different schools in the Valley. This graphic actually shows a little bit about part of what the idea of maker spaces are, or at least makerspace science is, and what we're trying to do. And it usually starts out with an open science idea, something that a problem somebody wants to solve. And then it moves into this research component, ultimately implementing in some case, testing, and then producing what we sometimes call an instructable, some type of document that describes what they built. And then reflect on that for version 1, and then it circles back up, and then you continue on. So that flow is kind of what this course is about and what we're trying to do with this course. And in this episode, we're going to be showing you 3 different projects underway at UMass Amherst that's related to this class. One is on an air pollution sensor, another is on a water pollution sensor, and the third is a project we call World Librarian, which is a little different from the other 2, but really a fun project. And so I'm going to be making a couple important points as we go through this. And so turning to the first group, the air sensor group, who is about to come up, the point I want to make is the promise of what I call longitudinal makerspace science. Now, what do I mean by that? In the slide here, we've been teaching this class for about 4 years, it's teaching isn't the right word, facilitating is the right word. The students come in and work on projects, and we actually facilitate through getting equipment for them and other things. And on the slide, if you see in the fall of 2014, this air quality sensor project started with an integrated concentration of science student named Liz in the left side of the slide. And Liz wanted to create an air pollution sensor. She was worried about asthma and air pollution in the valley, the Pioneer Valley. And so we said, okay, Liz, let's try to figure out if we can make it. And through that semester, she met up with a Professor Rick Peltier in public health in Amherst, UMass Amherst, and also Steve Brewer, who's in the picture as well. And they mentored Liz toward building an air quality sensor a first version of it. After that, over the course of 2 more semesters, there was a handoff to other students who continued to refine and develop the air quality sensor. What I'm going to do now is bring up the team who's in now the third class build of this, and they're going to talk about what it was like building this air quality sensor. So team, come on up.
Hi, my name is Ibrahim Tahoon. We're part of the air sensor team in our Makerspace course at UMass. I'm a computer engineer.
I am Josh, and I am an electrical engineer.
My name is Simon. I'm also computer engineering.
Okay, yeah. So our sensor here is an Arduino-based air quality sensor, and what's within it is a temperature and humidity sensor, which is this white cube right here. And in the middle of the sensor, which you could probably see in there in black, is the dust sensor. And what this whole device is supposed to do is to be a cheap alternative to a lot more expensive aerosol and air quality testing devices. And it can give data based off of the humidity, temperature, and particulate matter within the air around it, and can work as an indicator for the air quality around it.
So for the air sensor, the code was all done through the Arduino program with the Arduino microcontroller. And we have to present an example of the code that we use, as well as the data that is being received by the dust sensor. And on the screen, as you can see, it's just constantly reading the amount of dust that is in the air. And it's measuring the parts per million of dust particles that are being measured at that particular moment. And right now it's pretty stable, because obviously nothing is being done to the air that would affect the quality at all. But if we were to maybe light a candle or cook something, then that would have an effect on the dust that is in the air, which would cause the numbers to either go up or down. And so what the sensor does, or the code for the sensor does, is that it records every so often, I think it's every 30 seconds, a snapshot of what the temperature, as well as the dust concentration and the humidity in the air is, and it writes it into an SD card, which is then removed and taken for data, which then can be analyzed for someone who wants to maybe do experiments or measurements with the air quality in a particular area.
It has one microcontroller. This is just a bridge to connect it to other components. This is a SD card recorder. That's the temperature and humidity sensor, and dust sensors at the back here. And basically, the microcontroller collects what comes from both the sensors and records it onto the SD card, which, as Josh said, you could later take it out and put it in your computer and see what the data is.
So what makes this project maybe different from other makerspace projects is that it is an open source project. As Charlie mentioned, it was actually started by another student a couple of years ago. And we have actually been in contact with one of the students who has continued that project. His name is Ben Lassen, and he's actually been very helpful to us in seeking guidance for the project. I've been in contact with him a couple of times because he works in the aerosol sensing lab at UMass, and he really knows a lot about the inner workings of this sensor. And we've gone to him a few times with questions about how it worked, and he's been very helpful with explaining to us exactly what the sensor is doing and what the different components are supposed to do and how to wire it. So it's really been helpful having an open source framework where we can constantly communicate with other students who've already worked on it. And it makes for us working on the project, a lot easier when it comes to seeking help. And we are going to continue working on the project in the future. I'm taking the class next semester. I don't think they are, but no. But other future students will have like the option to talk to me, and like I can help them with like knowledge that I have learned from the previous students who have taken this class to make like to achieve like goals that we wouldn't have been able to do had it just been from one semester. So by having this project as an open sourced project that spans multiple semesters, we've been able to accomplish a lot more.
We've had a lot of fun working on the project this semester, and I think we're looking forward to working on it probably next semester, depending on if we continue in the course or not. And I guess we can hand it back to Charlie.
So great job, air quality sensor, air pollution sensor team. As Josh closed in that closing, he was talking about the longitudinal potential of makers going from class to class. Now I've got a team coming up that's going to introduce the second point I wanted to make in this episode, which is the potential of cross-university or cross-organizational makerspace science. And this project is a water pollution project that the team will be showing you. And to set this up, this slide is talking about a colleague of ours in Colombia, in Bogota, Colombia, in the University of Los Andes. And down in Colombia, they've got these unbelievably terrible problems of illegal gold mining using mercury, and that mercury is getting into the ecosystem. And so Juan Camillo wanted to develop a sensor to help people understand whether mercury poisoning was going on in the water systems, as the slide's showing. So in the center picture, there's a graduate student, Sebastian, who's working at that university in Colombia. And Sebastian provided the students who are about to come up with initial information on how to build this water sensor that they had already developed. So at this point, I'm going to invite two of the team members to come up and talk about the water sensor that they built with the help of Sebastian in Colombia.
Hi, I'm Faith, and I'm a junior civil engineering student at UMass.
Hi, I'm Brian, and I'm a chemical engineer.
And as Charlie mentioned, the whole idea of our project was to replicate the water sensor that they built in Colombia here at UMass. The idea was to make a water sensor which would measure 4 parameters from the water: pH, conductivity, dissolved oxygen, and temperature, which when integrated are really indicative of water quality. So we tried to take the idea that Sebastian and Juan came up with and use it here. One of the things we came across was, for that team, they built their own device which would read data from the sensors and output it to the screen. So for purposes of time, we chose to purchase an Arduino Uno, which is seen here, to do that for us. So with that, the whole kind of work of this semester was figuring out, 1, how to connect the 4 sensors to our Arduino, and 2, how to compile a code which would operate with the Arduino and read in data from the sensors and output it to something understandable and useful to the screen. So obviously some problems we came across were, since it's an Arduino Uno, it's relatively small. So when we have it hooked up to all 4 sensors at once and a GPS in this picture, there's a lot going on, and you can kind of burn out some of the sensors, which we did to the pH sensor, and we had to buy a new one. So you have to kind of figure out a way to wire it so that they're not all interfering with both the data that they're reading in and also the way they're operating. Another big problem was figuring out how to get a code that would run all of the sensors at once and not break out when one sensor wasn't working, which we also came across. But overall, right now, we have a water sensor, a single unit with all of these hooked up, that is working. It's not with us right now. It's with our teammate who's actually working on it at the moment. But yeah.
Yep. So three things came out of this class for me. The first thing was my friends and I went to Hack UMass. We brought the water sensors there. and we won $2,000 worth of prizes for coming up with an idea, live water maps that can crowdsource and map out water quality data for anyone, anytime, anywhere. And this is useful in situations like in Puerto Rico where people are drinking from contaminated water sources and they're not sure which water sources are safe to use or not. And this is where the Arduino-based water sensor will be useful to help detect for chemical contaminants that people can follow up to do remediation and water filtering. Something else that came out from this class for me was my friends and I came up with a startup idea called Hydromarker. Our idea is to use drones to do water sensing. So by taking the Arduino-based water sensor and hooking it up to a drone, you can do water sensing faster and safer, and you can reach places that are hard to reach for humans. And the last thing that came out from this class for me is that my friends and I are going to Puerto Rico. We're part of a student club at UMass called Sustainability Projects Abroad. And we're going to be in Puerto Rico from January 2nd to 14th. And that's where we can field test some of these water sensors. In addition to bring water filters there, we are hoping that we can teach local people how to detect for water quality, for water contaminants, and then follow up with doing water filtering. And this can save lives. The last thing as to the future of our project, what we're hoping to do is we're hoping to create some kind of case that can hold everything together, and we're also planning for it to be modular, and so you can add on more sensors into it. And this will be useful for teaching kids how to about science and how to apply what they're learning in class into the real world. So if you watch this YouTube video, this shows how even a small kid can learn how to use these water sensors and be able to teach other people how to use it. So thank you.
Yeah, all in all, it was a good semester, and in the future, they might also be able to take the water sensor and test it and calibrate it at a Mill Valley station where some of the teachers at UMass have access. But yeah, and now we'd like to invite Charlie back up to introduce the next team.
Well, thanks, Faith and Brian. That was a great presentation on the air sensor. The point I want to just circle back to on that is for people watching around the valley, is there we were doing this longitudinal with Columbia, but there's no reason why we couldn't do this with a makerspace that's at Mount Holyoke or one of the other 5 college campuses, or even at high schools around the area or junior high at the area. So we're hoping that we can start to do this kind of cross-organizational making both in the local context as well. But now we're going to turn you to a totally different project, and this one's moving more into what Amherst Media is about, kind of local media and getting information to people. This project is a project where we're the team, Scott, who's about to come up here, and some other students that I've been working with, we've been getting information, largely video information to students in schools and libraries in Malawi in Africa. And so I'm going to now invite Scott up to talk about how we're trying to close the digital divide. That's on your screen is a map of the world's population. The red countries are ones where there's 70% or more people that don't have access to the internet. And we're trying to close that gap through the project Scott's about to talk about. So Scott, come on up.
So my name's Scott, and I'm a computer science student at UMass, and I'm part of the team that works on the World Librarian Project. And the big thing, as Charlie mentioned, is we're trying to close the digital divide between these countries that have internet, like the United States, and countries that don't really quite have the infrastructure needed for accessing the internet. And a lot of what we're trying to do is get educational resources to students, specifically in Malawi, to just give them information on things that they wouldn't always have access to. So a lot of the big thing that we try to focus on is that this isn't information that we're trying to force onto them. This is information that they request from us, and this is information that they want. And the reason why this is so important is that we're trying to create an environment where we're getting the information that they want rather than forcing on them something that they don't really want. And so I'm just going to walk you through sort of the way that we get information to and from areas with internet to areas without internet, because since they don't have internet, we can't just send the file directly to them. So there are a couple of components to our World Librarian system. And as you can see on your screen, we start with a requester. And this is usually someone at a school, and they typically have a data plan. And what they can do is, through a communication system, we use Twitter specifically, they can tweet out a request for information that, say, a student has requested, and then a peer searcher can find that information and send it to them. And we use a device called the Rachel Plus, which you can see here. And this is a small device built by an organization called World Possible. And it's basically a little Wi-Fi hotspot where we can put information directly onto this, and students can access it locally from wherever they are without needing to be connected to the internet. So the first part in this process of delivering information to schools is making a request. And so a group of students might request information on something as simple as brushing their teeth, or something as complex as building some big project, like say a farm or something like that, and information on that. So they'll send a request through, we have our own Twitter account, and they'll make a request to our Twitter account, and we'll see it pop up. And we have a list of the schools that we are currently working with, and we grab that request, and then once we acknowledge it, we use our students at UMass to look for information that students want. And the important part about this is that we're looking for open source digital content. And open source means that there's no copyright restrictions or limitations on the content that we're finding, because we don't want copyright issues, and that way we can send these information. It's built there for distribution wherever, or it's there so that like anyone can use it, and that's extremely important. And we've been mainly using videos because that's the easiest way to communicate information rather than using PDFs or something like that. So we look for this open source information. We use a variety of tools. You can even go on Google and just search open source science information, and you'll find it. And we accumulate a list of things that we might be potential candidates for the request, and then aggregate that down to usually a single file, to then send off. So we use Google Drive for this part, and we will save the file and send it over Google Drive to someone called Carl, and Carl has been integral in facilitating this, the transfer of information. So we send it to Carl, and then we tweet back to the school that we got their information and it's on the way. And what Carl will do is he will then let them know, he's there on the ground in Malawi, so he'll let them know that he has the information, and he'll get to the school, and they'll put it onto this Rachel Plus. That way, the students can access it from the school where they are without needing to connect to the internet. We continue to cycle for as often as they need, and whenever we get a request, as you can see, these are some examples of requests that we've gone through with the National Library System, Ballantrae branch, and the Green Malta School. And what's really cool about this is it doesn't require them to have an internet connection. So it really is, we're just trying to help people out in any way we can and provide them the tools that they need to advance themselves and learn about things that they're genuinely interested in only helps them. And that's like the biggest part about our project, and that's why at least I enjoy working on this project. So with that, I guess I'll toss it back to Charlie.
Thanks, Scott. Great job on that presentation. What we're about to show you now is a short video of some of the kids in Malawi that we're feeding that information to. And the one thing I wanted to add to what Scott said was, you'll see in this video kids with a little flash stick around their neck. This is called a key pod, and what that is a USB stick with an Android operating system. And so the kids in these really poor rural offline schools have access to refurbished laptops that don't have any hard drive, and they put the key pod into the USB and it boots up from their USB. So it's basically a little over, well, around $7 computer that all these kids are getting, that our colleague Carl in Malawi is giving to these schools. So that's how they're actually getting to the database that Scott was just telling you about on the Rachel device.
Hi, my name is Jem Clark. I'm the country manager at Joshua Trust in Malawi, and this is Chileweni Primary School in Malunga village in Blantyre Rural. Chileweni is a primary school catering for around 1,400 children from 11 surrounding villages in this community. It's an extremely impoverished community. The kids here face a real host of problems. Not least is access to quality education. Hence why we're here launching the KeyPod project. We have just installed the solar panels to power up to 10 laptops. We've got 8 laptops so far, and we're looking for a few more. And we've got a Rachel Plus on its way to us in the next couple of weeks, and we've got KeyPods also on their way to us. So it's all very exciting. And we're hoping that it's August now. We're hoping by September, when school opens again here in Chileweni, we will be good to go launching the KeyPod project.
But here's a short clip of our KeyPod point at the National Library Service in Blantyre using Rachel offline.
Hello, my name is Robert Manfumbo. I am responsible for the computers here at Blantyre Branch, and I'm also a KeyPod user. We did receive an assistance with the Rachel Plus device from the World Possible, with an assistant of Shift IT. They provided us with a KeyPod computer that we use in the library, and also the University of Massachusetts also help us to upload content, educational content requests that we send to them from our leaders. Or sometimes we do see the need, and then we tell them to upload the content we require. We have enjoyed Rachel Plus for over a couple of months now, with a daily attendance of 150 persons per day. We do save some of that amount with content from the Rachel Plus. Some do bring their laptops here with them so that they can access the Rachel Plus, and others will bring their phones which have Wi-Fi connections. We also do help those which we don't have with a KeyPod computer which we have in the lending department, that they can also access the Rachel content. When there's need arise, they send us with their requests, which we then upload and send them to the University of Massachusetts, which then upload the content into our device that the readers should use. Very soon, we'll roll out to some of our branches, now 15, because here we do have one, and then we have also one in Lilongwe, so we have 15 remaining centers that we need to roll out the Rachel Content Plus. Now we have connected the Rachel all around the library, wireless and even cable.
let me now thank everyone, thank the students. As you can tell, the students at UMass are just fantastic. They're doing great stuff. The points I was trying to make through this episode were, one, the importance of the longitudinal semester to semester and the potential of that. The second was the potential of cross-university or cross-organizational making that I hope through Makers at Amherst Media we can continue to push and get UMass and the 5 colleges and high schools in the Valley, junior high, all possibly following what we were doing with Columbia. And the third piece related to schools is we're moving to the point now where we're supporting these Malawi schools with the Rachel program, and there's no reason why we couldn't have kids in high schools in the area who are interested in studying a country like Malawi, who they're actually doing the searching for information to send to Malawi. So we can actually start to scale up and get help from schools in the area that might want to have kids search for content that we can send to Malawi in the way that Scott just showed. So with that, I'll close the episode. I really appreciate Amherst Media for all they're doing in terms of pushing forward the Makers at Amherst Media program and for making this episode possible. So thank you all.